Now we look at the instrumental variable estimator, how to derive it and its basic assumptions. So for the IV estimator, we need the two assumptions that are the exogeneity and the relevance. So the exogeneity states that we need that our instrument, that we call it Z, must be the covariance of Z and the residual of the model must be equal to 0. While the relevance states that the covariance of the instrument and the regressor must be not equal to 0. So we now derive our estimator. So to do that, we need to compute the covariance between Z and Y. We know that the covariance, so we know that Y is equal to beta 0 plus beta 1 times X plus the residual. So it will be equal to the covariance of Z and beta 0 plus beta 1 X plus U. So the covariance of these two will be equal to 0. The covariance of these two will be equal to beta 1 times the covariance of Z and X plus the covariance of Z and U. Now, by assumption, this will be equal to 0. So we are left with the covariance of Z and Y is equal to beta 1, the covariance times the covariance of Z and X. So the estimator finally will be equal to the covariance of Z and Y divided by the covariance of Z and X. So when we, this is like the population parameter, but when we are estimating with the instrumental variables, it will be equal to the sample covariance of Z and Y and the sample covariance of Z and X. So it could be n to the power of minus 1 times the sum of Zi minus the average Z times Yi divided by n to the power of minus 1 times the sum of Zi minus Z, the average Z, times Xi. Now we substitute Yi with beta 0 plus beta 1 X plus U, and then we will have that this will be equal to n to the power of minus 1 times the sum of Zi minus Z bar times beta 0 plus beta 1 X plus U divided by n to the power of minus 1 times the sum of Zi minus Z bar times Xi. Then we are left, this will be equal to, so the sum of this product will be 0. So we go directly to this. Then we notice that this will be equal to beta 1 times n to the power of minus 1 Zi minus Z bar Xi divided by n to the power of minus 1 times the sum of Zi minus Z bar times Xi. So those simplifies out. And then we are left with n to the power of minus 1 times the sum of Zi minus Z bar times Ui divided by n to the power of minus 1 times the sum of zi minus z bar times xi. So we have that the estimated beta with the instrumental variable will be equal to beta 1 plus n to the power of minus 1, the sum of zi minus z bar times ui, divided by n to the power of minus 1 times the sum of zi minus z bar times xi. Now we want to see why our assumption are crucial in a consistent estimate of beta 1 with instrumental variables. So when we want to analyze whether our estimator is consistent, we must take the probability limit of our estimator. So in the probability limit, the second term of the right hand side, that is this one, will be equal to the population covariance of z and u divided by the covariance, the population covariance of z and x. So the probability limit of beta 1 beta iv will be equal to beta 1 plus the covariance of z and u divided by the covariance of z and x. So this is the formula that shows how if the assumptions of instrumental variables are not met, then our estimate will be not consistent, because so if we recall the formula of the covariance, I write it here. The formula of the covariance of z and x will be also equal to the standard deviation of x times the standard deviation of z times the correlation of z and x, while the covariance of z and u will be equal to the standard deviation of u times the standard deviation of z times the correlation between z and u. So we can use these two to rewrite our probability limit of BIV, of beta IV, will be equal to beta 1 plus sigma u sigma z times the correlation of z and u times standard deviation of x times the standard deviation of z times the correlation between x and z. Those simplifies out. So with this formula we see that it is very important, it is crucial to have to have consistent estimate, to have the highest correlation of x and z, because we see that if this one is really small, it can lead to very high bias. It can lead to a very inconsistent estimate, because since it is in the denominator, we need it to be the greatest as possible. On the other side, so this is where the relevance assumption says, because we said it in the beginning, it must be not 0. It must be the highest possible, while in the numerator we see that this is the place where the exogeneity assumption works, because obviously since in the case it is not equal to 0, it will lead to inconsistent estimate.